Hello, sir. Are you ready?
Yes,
Hello.
yes. Yeah, hello.
हाँ sir. Okay, sir. Then your opinions over please start.
Sure, sir. Good afternoon, everyone. Welcome back to the FDP. As you all know, we are in the last session of FDP 2021. So let's get started. Analyzing and improving cybersecurity posture is not a human scale problem anymore. AI and machine learning have become the critical technologies in information security as they are able to quickly analyze millions of events and identify many different types of threats. The result is new levels of intelligence feeding human teams across diverse categories of cybersecurity, including IT asset inventory, threat exposure, controls effectiveness, breach risk prediction, and many more. I think you must have guessed the next topic. There is artificial intelligence for a smart detection of cybersecurity. To elaborate more on this topic, we have with us Engineer Subrat Kumar Acharya, sir, scientist and head of Bhuvan Systems and Networks at NRSC ISRO Hyderabad. We all must know him very well as we already have heard him in the previous sessions of this FTP. So without taking much of your time, let's directly hear from him. I'll request sir to begin the presentation, please.
Okay, thank you for the nice introduction. And let me start with my slide. Here or here? Okay, I hope the PPT is visible. Please confirm once.
No, sir, it's not visible yet.
Come here. What is that? Not visible.
Yes, sir, now it's visible.
That's visible. Okay. Once again, good afternoon to all. Today we'll discuss about this artificial intelligence for smart detection of cyber security. So in our previous topics also, some security related um, presentation was already there. But here what I will majorly focus is, as we know, in artificial intelligence, it needs a set of data on which analysis has to carry out. Now here we will focus on the cyber security related activities, like what are the data sources and what are the AI models to be established and how it can be a robust AI model, because security is always the topmost priority for any kind of web hosting or any kind of when it comes to internet related activities. So we'll start with this uh, major presentation, like this is the last presentation, because uh, I will focus more towards the building the model and their data sources. Okay, now the outline, basically here I want to focus about this cyber security aspects, like what are the aspects we have to think about when it comes to cyber security, and what are the AI models for building the cyber security threat detection, and then the automation, what we can bring by using the AI to ensure zero time to mitigation. Zero time to mitigation is like when any cyber security threat arises, how much time we have to take to mitigate it. So that way the time period should be as much as less possible we have to ensure. So towards that, the AI helps us to minimize this time so that we can ensure that there will be absolutely error security free, threat free. That is threat free operation is going on in across the internet domain. And then we'll also discuss about this deep behavioral analysis, like how the bots and the security behavior, how it depends on the behavior of the user or this operation happens. And then this machine learning and cyber security. This is also the how to establish this model so that we can build a proper AI model. Towards that also we'll discuss. And finally, I'll highlight on the AI and data center security. That is towards the practical approach. Today my session will be mostly towards how to collect this data, how to build the model, and how we have to ensure that all these data sources are in a particular format, and those things are properly taken into the model, and the security is ensured. So now, before starting this discussion about the AI on cybersecurity, first we have to discuss about this type of data, what is going to come to this analysis. And as we know, the data is various types, like structured data, unstructured data, the semi-structured data, and then reinforcement learning. That is, the major focus here is the data which is created real time for various exploration purpose. So why all these terms are there? So that means this will help us to select the model and the features. So let us start with this structured data. As we know, the structured data basically it will be in a particular form of record or in database kind of things, so that there will be proper relation for every piece of information, and that will be referred very fine-tune activities will happen with this, because this data set is properly, we can refer for any kind of any kind of model building activity. So coming to the unstructured data, as we know, there all this text or an image kind of data, from where deriving digital information will be very challenging task. But however, we have to bring every data to a particular format, so that this unstructured data also we can create a particular group or set of structured data and to build this model. So the basic aim of is to understand what are the four different set of data sets are used to build any particular model. And then semi-structured data will be some data which will have some references, as well as without any other reference, like as I said, so it will help for creating a particular record, and as well as it will have no proper hierarchy which will be created. And when we understand the type of data which is there to do this any particular activities on this, then when it comes to security analysis for the data, always each and bit of information of the data has to be understood properly by the model, and or by our program. Then from there deriving information will be, so it is basically to classify the data in a proper way, so that so now in our coming presentation, mostly will focus about Now, how these data sets are flowing from different type of devices. So what are the purpose-built devices are there which will create this type of data which is used for the security analysis, cyber security analysis, or any kind of security vulnerability analysis. So now let us focus about the data structure, whatever we know. When we go for different same set of data, so it will have different type of meaning. That means when you are building a model of cyber security, so when we take a particular picture, it will have different features, like it will have a color, or it can proper shape, or it can be proper logo, or it can be proper depending on its shape, whether it will be a what is the kind of image, or what the kind of feature that data is there, we can derive. So this is just to showcase how this information is being read by the artificial intelligence model, so that each bit of information is tagged with some piece of information. That means each feature is being analyzed as a particular event, like this will be called as a particular fruit, or a particular logo, shape. Those type of information will be created automatically by the model. So this is just to showcase how this unstructured data is read and created to a structured format. So this all structured formats will be created. This is just one set of data, how this different information is being derived, and from there, how we'll correlate with this data, and bring out our security feature, or security enabled information, so that it will help us to understand to do our activity. Now, as I explained in the previous presentation also, that was for the load balancing activities, and here also this model, it is just to showcase how this model is being built. So the main focus today's presentation will have the data sources. So once data sources are there, and what are the sources we have to take, like previous session also we had a proper presentation on this data sources for different load balancing activities. So here the data sets will be mostly what are the security devices are available, or what are the security data sets we have to collect, and so that we can bring our model in a particular purpose built mechanism, so that it will do a particular analysis and embrace some prediction models. Hello. So based on this prediction models, we can take better decision, and then this data validation will happen. And then this data validation will happen, and voice is breaking. My voice is audible, or it is breaking? Okay, some problem is there. It's fine. Maybe okay. Is it breaking for all? Can anybody else can confirm? There, where you are checking? Huh?
No, it is absolutely fine. Please go ahead.
Maybe we'll continue, or is it breaking continuously? Am I audible?
Your voice is perfectly okay, sir. The other participant might have some internet issues, I think.
Okay.
Yes, yes.
Thank you. Thank you for
Please
confirming.
continue.
Thank you, sir.
Sound is full stand, no? This one. Slideshow. Now it's coming. It's coming there. No? Then why it has come like this? Okay. So now we'll continue with our presentation. Now this model, whatever we are discussing, like the set of data sets will be there from the various devices, and then it will be taken into particular model, and this decision making algorithm will be there, and then validation will be there with the ground validity. So here the classifications are like data sources and proper analytical model, then prediction model and validation, and then feedback will be there. So feedback is basically when we get a particular event, that event, whether it is the true event or false event, those type of information also we have to give to the analytical model, so that we can do this prediction in a better way. I'm getting some disturbance. Who is that? Lila Kumar is having some problem. So now coming to the model, like the model is styled representation, and how this model is basically is being built, that we are going to discuss with some historical data. Now here we'll have some training data sets, then we'll have one validation data set. So training data set is like the known data, whatever we have, and then known response will be there for the validation data. And the new data, like the test data, that is also one data set we have to take, and then we have to bring them to a estimated model, and then general analysis will be done, and then test field data is the general model. That means the field data also we have to take into consideration while validating this, and then this learning we have to update the model with the new data, so that new data also will take as a feedback to the our original training data and validation data. So this is only to showcase how the model is being built with different type of data. Coming to the AI on cyber security, like first we have to focus on this requirements. So what are the key requirements? So number one is we have to create a proper, to build a proper AI model, we need proper data sets. So that is the most important factor, and there we have to see like what are the maximum sources of information we can give, that will be there for the model building. Now coming to after the proper data set, we have to see a proper AI model for that. So as we know, different type of platforms are available that we are going to discuss, particularly what are the major platforms that are used security analysis, so that we are going to discuss in much details. And then this data and data set, when it comes to the particular model, it has to be properly validated. So these are the three prime requirements on which this AI model for the cyber security will be there. So what is the advantage why we are building this cyber security model is we have to get a proper accuracy. That means the accuracy of the model has to be so perfect, so that the on ground the validation of this threat, or validation of this prediction of this threat, those nothing has to be very accurate. So then the acceleration. That means acceleration. What here I mean is when we see any type of threat or any type of protection building mechanism we have to build, there it will to take any action on this threat or any kind of action to know the known activities like known damages can happen to our network. So how to minimize that time gap? So that is the acceleration. What I mean is, so the time taken to detect and protect. So that is the kind of activity. Then now over to that, it takes automation. So the final term is instead of doing manual action for any kind of threat analysis, so we are building automated mechanism. And the key factor, as I repeat once again, is it needs a proper input data. Now let us start with our presentation for this doing this type of security cyber threat activities. Now this PPT, what I'm going to show is I'm going to build a model for a data center. What are the devices are there, and these are the devices when this data I'm taking as input for my model, and what are the how to build that exercise that I'm going to show. So now here, as we know, this when any kind of data center in that devices like server, storage, and we'll have internal switches and firewall protection security device also will be there. So this type of devices, when we collect data and application related vulnerability, that is also one model to this input. So each device by device we are going to see what are the input data sets that can flow to this, and so that this cyber threat activities towards the application hosting or any kind of setup which will be required for serving the data over the internet domain, that will be taken care properly. So let us start with this classification of this security operations. So as we know, this security operations that happens over network level, and then it comes to security system security level, then it comes to application security level, and then data security level, and of course the physical security also is one of the parameter. So these are the sources of information where we have to feed data to this model. So let us start one by one. The network security is like what are the devices available inside the premises. So they are basically this firewall and their intrusion prevention system and SSL encryption. Like these are the protocols whatever we use for this network layer security. So those type of information, device level information, that is required for this. Then coming to the systems level security, so whether it is properly password protected devices are there, or any OS related vulnerabilities are there, or in to management of users, that means any LDAP or those kind of protection is there or not. So these all information we have to give for the model. And probably is there any antivirus solution is available or not, those type of data we have to take into consideration. And each device level information, like which is how many servers are there, how many antiviruses, when it was loaded into the last date of security patches upgradation, those type of minute information also we have to give to this model. So this comes to system level security. Then coming to the application level security, like as we know, web vulnerability scanners, then web application firewall, and then data backup mechanism. So what I mean here is like when we do any kind of application development, and then on the lab level we use lot of security analytics tools, vulnerability tools will be there, and we validate through different type of tools so that we will get error-free operation for our error-free means like is whatever vulnerability will be there, maximum to maximum there will be corrections while deploying in the live operation. So what happens next is there will be again particular dedicated appliances will be there, that is called web application firewall. So the job of the security scanner, what we do in lab level, the same thing will happen in the device level, that is called web application firewall. Apart from that, this you will have internal IP database also. That means it can say if any vulnerability or any attacker is trying to do any kind of operation from a remote place, and what is his intention, or what is the minute information about this this web application device will collect, and it will keep it in database. So this data also required when we build our AI model for cybersecurity. Coming to the next data backup, like whether this particular data is sometimes the attackers, what they do is they will only see which data is not duplicate available, so that they will first try to destroy those single point of failure data, so that the end user will be critically into trouble. So that type of mechanism, cyber security domain is so strong in those type of activities. So this type of minute analysis also happens. So towards that also we have to see which data is whether proper backup is there, or what is the level of backup. Like sometimes data will be there in 1 copy, 2 copy, or it will be different tier of storages. Those type of information also we have to give to this model when it comes to application security level input. And coming to the data security, like data authentication, then data protection, those type of operations are there. So those whether data is properly authenticated, validated, or any protection mechanism, or like encryption, encrypted data, whether this type of information also is required to do any kind of proper AI build cyber threat protection mechanism. And of course this physical security, how important it is, now I am going to show in my particular next topic. And it basically it will collect the restricted management access. That means towards the data center, how many people are working, or who are the intended people to do any particular device level operation, those type of information. Let us say one person who is supposed to do the server action, and if his intention is to do some any attack activities, then he may land into some other device and do some problems. So that so the validation of this people who are really intended to do particular operation, that information also is required for this. And then as we know, IP camera, so this IP camera is basically it is collecting set of images, and that image validation and how this image data and streaming data is recorded for this input, so that it can properly do operation, probably build strong AI model can be built up. That I am going to show one short video also on this particularly how this Google, as we know today, they are the leaders into this domain when it comes to cyber threat or any kind of activities. And I have only just chosen one small video also I'm going to show in afterwards. So in this, what we got is what are the AI-enabled services security platforms. So as we have discussed now, for this model, to build a proper model, what are the data sources? And here I am again tabulating them. What are the sources of information is required? AI-enabled IP surveillance and detection and access control, that is for physical protection. Then dealing with malwares. Malwares are there in the network, how they spread their actions. Those type of information is required, and how we mitigate them, that is also required. Then spam and social engineering. So spam is we know the mail activities. So how this happens in a protected environment. And then traffic analyzer. So network traffic, we know when any attack happens, there will be a different behavior in the normal traffic, and when it comes to particular traffic which is already compromised. So those type of analysis patterns we have to see. And the bots, like all the programs, will be there. And DDoS, that is distributed denial of service. So I think these are the very common things which is happening nowadays internet domain. So now those and those things, how to mitigate them, that data sources also required. Then the NGFW, this each device, each data sources, again I am going to explain. So what are their functionalities and how this data is very useful for this domain. So this NGFW is next generation web firewall. That is traditional network firewalls will have its protocol for this firewall activities, but along with that it will have all the content filtering and various kind of scripting activities. Even IP database also we can integrate into it, so that it will look for a particular behavior of or the user centric cluster centric applications also it will monitor. Then user behavior analysis, that is one of the very state of the art actions that is going on. So how we get the behavior analysis data, that also I'm going to project. Then intrusion detection and intrusion prevention. As we know, this network activities, when it happens, so outside attackers, mostly they compromise either the data or the access pattern. So access pattern, when I say the network disruption. So network disruption, for that, what there will be a dedicated detection mechanism and prevention mechanism. Devices are also available, and those pattern data are being has been taken, and that will be given to this model. And of course, this web application firewall, like it will have the signature of these vulnerabilities, the site scripting and SQL injection, those type, whatever the OWASP attacks classifications are there, those type of things. We can either it will have a signature based WAF, or we can build our purposeful WAF. That each of these actions we will present in our coming we'll discuss in our coming PPTs. So let us start with AI automation to ensure zero time mitigation. So we are now going to do each device level data, how this data is being captured, and this data is being fed to the model, and we are going to build a particular cyber threat AI enabled platform. So we'll start with this physical surveillance and this physical content security. So here I want to present one video that you can see the Google how they maintain particular layered security. Yeah, maintain this layered security, that is focus. So here, what I wanted to show is like there will be a different layer of securities, how it is being maintained. But this, I hope this video is not running. Watch नहीं आ रहा? अरे why was should come? Okay, maybe. Need to check. So I hope this maybe voice is having some issue, and here I wanted to show is like they are maintaining the different level of security when it comes to physical security. So what are the levels is like one will be camera data will be there, and access control also will be there. Then iris, like our eye scanning also will be there. Then pattern validation, like whether I'm moving in a right direction or wrong direction, those type of information will be there. Then there will be a checks, like there will be a validation of all your authentication, documentation, those types of things will be there. Then even the physical disks also, there will be once it is used or due to any reason it is damaged or any kind of non-operation of the devices also, that is completely destroyed, so that by any chance no information will come out. So even the device operation level things are device is not in operation also, since it is used for public information, that type of the devices will be completely physically destroyed. So when we talk about physical security, how each layer of information is being fed to our AI model, and that is going to give us the information about the physical level security. So the purpose is movement is detection and the smart image detection, that is through the IP cameras. And the layered security, that is, as I said, your access control, I pattern, then there will be disk level physical access, those type of physical actions, whatever are there, that is being properly tabulated, and these all are taken into input to this model. So this is about this physical security. Then coming to the malware, as we know, traditional malware solutions like regular firewalls, that is detected by signature based mechanism. So that means we'll have some set of signatures, or we'll have iOS, that is internal OS for that devices. That is firewall will have its own different OEMs models will be there, and each OEM will have their own signature, like antivirus. They will build their own signature models, and that will be there. And traditional firewalls, that is being used to protect from these malwares. And of course, there are many learning exercises are happening to deal with this type of analysis. Those type of information also it is required to this model, and instead they can learn systems and they can recognize suspicious activities, that is these malwares. They can detect what are the system related activities or any kind of actions what is going on. Traditional firewalls or any kind of deep learning detections are there. So those type of access pattern that is being fed to this model about this malware activities. And coming to the spam and social engineering detection, that is unwanted mails like bulk mails which is not regularly supposed to be there. So spam activities. Then nowadays, of course, this NLP has come up to detect and deal with this social activities of huge information which is flowing across the social network. And I found one of the very good platform how Google has used for this Gmail activities. Maybe this PPT I will share afterwards. You please go through. This will be very good piece of information. I found that they are using one AI model, and that is open discussion is there, on which they are discussing how the Gmail model they have built. That will give one insight for this link also I have given. Maybe we'll separately discuss on that. And coming to the network security, network traffic analysis, that is network traffic means, as we know, each country will have its internet network or internet whatever maybe, and they will have a access pattern over the weekly, monthly, yearly, those kind of actions. And there is a trend across the world that with these countries a classification among the countries. That means let us say here, as we see green color, the India Australian region, it is showing green color. So there will be a trend particular area. That means large users are there. So when it comes to another classification, those that is here classified as mid application, mid users. And then some other country classifications. Why we are doing this classification is, once we do that, if any abnormality is observed, let us say these countries like South America or African region that is showing as low network analysis. So suddenly, suppose there is a peak or sudden there is a change, because there will be access pattern over yearly or continuous yearly basis. Available data will be there. If there is an abnormality, those abnormalities are input for this. So that's why this network traffic analysis also plays a major role when, and that is being this type of information, like we are having IP information over the world, and whatever website or domain information over the world. Similarly, this data is being released in hourly basis what is the access pattern of each area, each country, or each continent, like that information will be there. So that information, when it is being used for this security operations or model, then that will give a huge impact for this doing this analysis. So here, as you know, that HTTPS network traffic look for the malicious activity. That means if any malicious activities are happening or anything is going on, it will concentrate instantly tell us that this action has happened. Because of that, this has resulted into some malicious activities. So this type of information, data we have to give to our model. Then this is very useful to deal with many cyber threats such as SQL injection, DOS attacks. And DOS attacks, as we know, and that is denial of service. So when denial of service commands or whatever action happens for our website or cyber action threat actions, it is very important to know how, from where it has originated. So this type of information, or either whether it is originated or whether it has happened. So those both the information that is being tabulated, and this type of tabulation is called set of malicious IPs, or set of activities where all these events has happened. So we have to see the concentration level of this operations, like which area. Once we tabulate, or these tabulations are already available across the different platforms. So these all when it coming to our model, then that will give a minute level information about the DOS attacks. So immediately we can concentrate that this country generally, when anything happens, there will be 80% of chances or 90% of chances that this country can do. So those type of information is derived from this model, because we have the past event data is available for this DOS attacks or SQL injections. So that is why this network traffic analysis is very important for doing this analysis. And coming to the deep behavioral analysis to detect bad bots. So bots are basically the small programs, and as we know, the network traffics that is being generated by these bots, and how these bots they um, do any kind of action that is being highlighted here, like it includes it's a takeover, account takeover. That means when I want to access one particular website, that will be showing me the similar website or similar actions. So that way, this account takeover that is being highlighted here. And grabbing up the data, like any I am hosting one website, there will be some changes in my data. So that may happen on the real-time operations also. So how to avoid that data. Then denying available inventory. That means when you look for certain particular sets of data that is not available. It is basically the difference between the denial of service and denial of inventory is denial of service. As we know, there will be complete stop of the service, and whereas the compromised data, that is only here we are classifying as denying available inventory. So these are very suspicious activities. Those things also are coming input for this model. And here now we are taking one by one tables from where these data sets are being flowing, and then this will be there for this any action. Now how these bots we can mitigate here. As we know, this intent-based deep behavior analysis. So what happens? So what we know is bots are basically some scripts and how they do different level of operations, and The bots, there will be a blacklist. That means in the device or in the program, we can create some blacklist table also. And then we can, next level, we can say these are the device means here it is referred as this particular service or this particular action. So those are, that is also being tabulated. And then there will be proper interaction in the among other set of data, and what is the intent for that doing that action, that is being studied in the model. So it is basically to know the analysis behavior of this intent, and that is being analyzed. Then, as you know, this and the behavioral analysis, that is what are the steps is we have to first encode the intent. And intent means like I will just go to access particular website. Those signatures will be taken as a reference. But when it comes to certain activities like attack activities, how this happens. So I can have a complete comparison because I have created this encoding. So similarly, this intent analysis. So once I create my encoding, and I will come as an end user or come as an attacker, and I will create the comparison between my encoding data and whatever real simulated data. So that way it is called analysis. I have to create and to build a signature for this. Then adaptive learning is over the period it will take all this collects the prediction information and predicts the model based on this requirement. So what happens here is like this generally we are using this CAPTCHA or SMS OTP and all, and there will be a particular pattern. So that pattern also is being studied by those some type of attackers. So we have to also see how frequently this CAPTCHA type of CAPTCHA or SMS OTP pattern, like whether it should be 4-digit, 5-digit, 6-digit. It should not be over the period of long time for a particular pattern. So that is basically adaptive mechanism on which we have to create, so that there should not be a complete set of actions which are being tabulated. So that is basically the behavior analysis what we do, these 3 steps. Now we'll focus on this behavioral analysis, that is DDoS, distributed denial of service. So what happens in a distributed denial service, as we know, there will be a multiple sources for the same event will be there, and the server or whatever endpoint will look like it will have it will look like validated data, but whereas this will be created by a particular single attacker. So how to detect those type of things, and what are the, so each action what I'm discussing here is each all this signatures is being captured by particular devices, like what I explained earlier, IDV actions or bots, and now DDoS. These all are being captured by either this network firewall or DDoS appliances are there. So we have to ensure that these are the actions what happening. We have to create a log mechanism or collection mechanism. So how to create this collection mechanism? For DDoS appliances will be there. Then for network related activities, firewall logs will be there. Then when it comes to application vulnerability, for that application vulnerability devices will be there. So nowadays to create a data particular format, so appliances, various appliances are there which will create data particular signature based actions, and those type of information will come to our model to create a proper secure environment. So here the DDoS attacks are hard to detect, and because it is being created by same user, but only we have to create this particular pattern, and that pattern is being studied by that particular signature, and that will detect as whether it is DDoS attack or any real authenticated users are there. So what happens here, just to showcase, is the DDoS attacks are very voluminous, like same resolution will come from a particular attacker, and multiple some requests will at a time land into this target victim. Target victim here, what I was referring is the machine where the attackers will land and do their actions. Then what are the challenges with this traditional security devices? As we know, traditional DDoS solutions, the solutions use rate limiting and manual signature based attacks. So that means it will have its own signatures, and that signature, once it is validating, then it will go show as a particular behavior or that type of DDoS attack. But how to see that in a real-time environment, whether the DDoS attack has happened because of it is only to the which layer it is affecting, what actions are being compromised, those type of information again we can derive from that, from our analysis model. So here just I am showing one defense pro. Defense pro is basically one particular set of architecture, or we can say it is one model subset where we are classifying these DDoS attacks, whether it is network level. Here I'm showing L2, L3, L3, L4 activities and application attacks. So the attacker, whether he wanted to do any action on this network level or application level. So those type of inbuilt in-depth information that will be there. So what I'm referring here, defense pro, is like it will have again some signatures will be created based on these layers also. As we know, our OSI layers are there, and based on that, which layer it is trying to affect, and in-depth analysis that is being carried out. So, and the DDoS, why I'm focusing more here is, which is very prominent, and nowadays most of the attackers, whatever the intent is, how to they will stop your service, because from entering into the network and doing actions nowadays very difficult, but it looks like it will create such a load that your services will be stopped. But those type of actions, now I'm just showing one small video. So here just I wanted to show is like in real-time environment, how these devices like web application firewall or any kind of real-time attacks, how this is being mitigated by DDoS or web application firewall. So that one only the main I was trying to show here. Then coming to the deep behavioral analysis of the IPS and IDS. So IPS, as we know, intrusion prevention system or intrusion detection system. So every term we are referring in terms of deep behavioral analysis because these all are different signatures. Particularly this DDoS, they will have one particular pattern. Then firewall will have one particular pattern. Then IPS will have again its own pattern. So now coming to this IPS or IDS, as we know, it will have again known signature attackers, known signature based sets will be there, and which it will again detect any of the IP patterns, and whatever pattern, if it is validation is not happening, it will detect as a threat. So when we collect multiple information from this multiple devices, it is all information we are giving to our model, and here just showing that many solutions are available, like next generation firewall and web application firewall, or purpose build end user entity behavior analysis tools also are available. So that can be used to integrate to this model. So coming to the next generation firewall, as we know, the traditional firewalls will have its protocols in the network level or like that. Then, but when it comes to this next generation firewall, it will have its additional features, like it firewall. Along with that, it can have intrusion prevention system or an SSL traffic inspection or any website filtering. As you know, this filtering of the content we can do. Then quality of bandwidth management, like earlier days, only single firewall will be used, or we have multiple networks are there. What are the rules we have to create for different different networks that can be properly saved in this thing. And then antivirus, as we know, the firewall will have nowadays antivirus protections also, and authentication, or like Active Directory or LDAP management also. So these all features, including them, it is being combined together, and that is being considered as next generation firewall. So again, we'll come to the final. What is the behavior analytics we are discussing? So here, what we are doing is we are taking the pattern from this traffic, and then we're tracking the data, and we're recognizing them, their activities. So that is basically we can see the different patterns of these actions, and those actions are being taken as input to this model. So again, I am focusing on this user behavior analysis. Is they will have data analytics, data integration, and data presentation. That means it will collect a set of data for the analytics, and how each data means where we all together data will come, and then they will among this data whether it will do any particular intent or behavior, that will be taken as a input. So now coming to the fourth device, that is web application firewall. So as we know, web application firewall is it is nothing but to take the vulnerability, application level vulnerability. It has to take care, and basically it will block the traffic based on the signatures of the application level vulnerability, and application vulnerability vulnerabilities, as we know, the common vulnerability like cross-site scripting and SQL injection, or this file inclusion, or proper system configuration. So those type of signatures will be there in the application firewall. And also we can integrate our IP database to these signatures also, so that our the attacker's location along with their place information and what are the behavior or density of these actions. Suppose one particular attacker is coming frequently to do any action, that is only called density based attackers. So those type of easy signatures that can be detected early. So that is what we are discussing about WAF, and that WAF will collect information, and these all devices will have different patterns, and those data will come to the input for our model. Now coming to the solutions available, as we discussed, the various kind of input sources are there for the security devices, and we know these devices, whether we can get that service on premises, or as we know, cloud is becoming very popular to get that of services. What I'm referring here is I can get cloud services for this DDoS or my web application firewall, application next generation firewall. Those type of devices data, when I do for my security analysis, I can get them from to get a service over the cloud also. But provided like organizations like us, they will promote for the in-premises activities, because the cloud, as we know, that itself is another security challenge, because the data is traveling over the network. So this kind of solutions here basically classified at on-premises and cloud-based solution, and the main purpose is we have to deploy that feature and do the analysis and the protection. So what feature deployment I am referring here is the cloud, whatever security devices that gives log to do my cyber threat over the artificial intelligence model. That is what I'm referring as deployment. So some 4 or 5 set of data now, like DDoS data, then firewall data, then we got next generation what is called web application firewall data, then IPS or IDS data, then we create the behavior analysis. So all these data patterns now available for making them ready for my security analysis. So again, there is a small comparison between this on-premises and cloud-based solutions. We know this cloud-based solutions, no installation required, or only it is basically one feature we have to take from the service provider. And on-premises like IPS or this IDS devices, and this web application firewall devices, network firewall devices, or DDoS devices, those devices we have to position in our premises, and from there we'll take the log and feed into our model, and that will give us a real-time warning or real-time detection mechanism. So now coming to the data center, how exactly it happens, all these operations. So when it comes to the data center, here we have to see the efficiency and optimization angle. So data center, a lot of data will be available, like your cooling information, space information, power information, cabling, port information, server optimization, workload. Why I'm referring all these terms are that each term, each data, like cooling utilization, let us say only one point, cooling information. So cooling information, why I'm feeding this data to my security analysis. So what happens? Any event happens due to certain reason, one particular server will go and run in a high mode, and that will consume more thermal thermal consumption will happen more. So that is one unwanted behavior. So that is why I need all the information with what are the traditional what are the traditional sources are there. I should know all this input data to my model. Similarly, every data is being taken, minute level data is being taken to my security model analysis, so that any change in power, change in cooling, or any root cause, any failure has happened, whether that failure is particularly happening in that particular server, always that itself is one input. That only I'm referring here as a root cause analysis, what I'm referring. So then coming to the okay, now next the capacity planning, like the best placement, best place to place the server, and then security analysis, like the image recognition from surveillance camera or IT network surveillance. So those type of event data also is required. Now the final action is like when I'm doing any particular operation, what are the risks are involved, that should be very much known before doing any kind of operation. So what we are showing is we are building a model, since it is security events and cyber detection activities. So towards this 100%, that if 100% is achieved, then there is no security threat. So what happens, there will always be a trade-off between what you want and what exactly we got. So that is why, that is how these models work. So what are the risks here classified as? There will be, first one is called bias. So bias, what it does is like will have human nature, all those type of indents will be there, whether that is there. So whether there is, sometimes there will be a proper indent or sometimes there will be no intent. So those type of actions, how to differentiate whether any kind of indent we can call it as a bias. So those type of always interpretation will be there. So coming to the next, like there will be a change in training data or change in test data. Those kind of operation also happen due to many reasons. This model what we are building, due to change in data sets also, there will be erroneous output will come. And then how the decisions are made. So liability is like the data whatever we are giving, so for training data or feedback data or validation data. So who is the liable for that data? Suppose whether any authenticity is there to do this type of operation or validation, those type of decisions, how to make in a perfect manner. So there only it brings a risk factor. And then how long this model will build. What we are discussing is like once we build my model, whether that will valid lifelong. No, because this set of signature, and when we are telling about the behavioral analysis, the behavioral analysis is meaning is very much valid when there will be a change. So that change we have to adopt as a input to this model. Then repeatable analytic development process. That means whether our analytical model, what we are doing, is there any proper repeatable is available, or any development process, if any process protocol errors are there. So that is also is one risk factor for our activities. And again, the data and model, so when they combine together, what is the output? As we know all, So 100% when it comes to security event operations, that is always one question mark. But our aim of this model should always be towards achieving this. So that is why this activity of machine learning, what we are discussing, that is being called as a face shield to escape from cyber threats. So we are now building our models with a set of data, and that data sets are validated, and as we have discussed in the previous slide, that there will be risks associated. So of course the risk we have to minimize, and we have to create a shield across our activities. That is what here the meaning is. And coming to the main operation, what we are discussing till now is, when it goes to security operation center, we'll have the prime aim is we have to protect the data or protect the actions whatever we are doing. To do that, we have to detect if is there any changes or is there any events are happened, and then based on that events we have to send the respond to that activity. So what we are referring here is, number one is SIEM, SIEM, that is security information and event management tools. So what happens here, it will have all the event monitoring mechanism will be there, like starting from device level operations, and then security vulnerable tools, email alerts. So what I'm referring here is, like in normal security operation center, we'll have event monitoring tools, then security vulnerability tools that we discussed about web application firewall or any security vulnerability tools will be there in the development environment. Then email alert. So email alert is primarily for the how fast the event is being reported. So thereby this email event alert mechanism also plays major role. And smart support and correction. So there will be a team always active for any kind of event, whether it is created by the SIM or it is created by the web vulnerability tool, or it is created by the email alert. So all are happening through a particular support team, and they will be correcting. And of course, there are complaints and guidance are there. So there will be periodic auditing of these actions, and that will be ensured that all the actions what we are doing, that is being taken care as per standards. So as I said, the security operation center, the primary operation will be log collection, then log collection, then reporting, and R&D activities, like suppose we got some data, then that data, whether it should be used for any taking action or it is just required for our upcoming action. So that is there only it is called as research and development. Then threat and intelligence, whether any threat is noted or any actions we have to do. And knowledge base means whatever the data we have collected, is all we are keeping it for whether any real-time validation or real-time action is required, or any knowledge database only we are creating. Then ticketing is as I said, the email based alerts or events. Each event has to be time stamped if anything goes wrong in terms of the purpose and in terms of the intent. And then these all are reported in the same tool, and correlation will be created among all. So all means here once again I am highlighting, you'll have same tools that will give one set of data, then vulnerability tools that will give one set of data, email That is one set of data. Then smart support or correction. These are the that is all human related activities. That is the actions we are doing. So support and correction. So what are the corrections we did, or what are the actions we did? That itself is another data set. So those all are being created in the security operations center. Now coming to the our main aim, like when we are building this AI for data center activities, and we have discussed that there are different level of application layers are there. So when it comes to physical security, what are the devices where I will get data, that is access control, and then IP camera based or solutions will be there. So those data sets that will be coming to the my model, and physical security that we can take that data as input. Now when it comes to system security, as I said earlier, these all data sets are very much required either through any dedicated appliance, or we have to take this data directly from this let us say password combination. So password combination, when we say we have created one method for our password combination, and where that method should be valid for life forever, or we should there should be a change in this password combination method. So those type of information also required. Then server hardening. As we know, this server hardening like port level, whatever filtering is required, or any password mechanism in the OS, or bandwidth setting. So server hardening is related to what are the extractions we are doing for a proper or efficient detection mechanism. So that is related to server hardening. And then smart tagging based asset monitoring. Smart tagging based asset monitoring means, let us say we have some 500 devices are there in the data centers, starting from your switches, routers, and firewalls. Some many products will be there. So if I'm sitting in my control room and one device goes out, so how to detect? So nowadays the smart tagging based asset monitoring tools are available. So it will have one Wi-Fi range. If it is going beyond that, that will create one data set, that is either alert. That alert will be taken as input to my model. So that is I am referring as smart tag based asset monitoring. So these all are practically being used and in major data centers, and those are creating a set of data for security alerts. So those alerts we are now taking input to our model. Now coming to the next network security level, and when we talk about network security level, the IP scan tool, IP location database, then intrusion prevention interfaces, which we discussed devices level, then software defined network, those interfaces, or DDoS interfaces. So here I'm referring here interfaces is each level of information we have to take input to our model, so that the network level, what are the challenges, system level, what are the challenges, or physical level, what are the challenges, all together when they combine, that will be decided based on our model, whatever required for the analysis. Next comes to this data security in data security. So data security, when we say, that is that the data authentication. So authentication, whether it is my data or whether it is created by X agency or Y agency, those type of information or is required. That means data validation, and towards that also information is required. Data protection is, as you know, there will be change of data or any database changes. or any of my unstructured file, any property somebody has changed, those type of information that is required. And AAA interface, as we know, these all are related to data security AI interfaces. Coming to the application level security, web vulnerability tools, which we are normally using for any kind of software development, and web-based solutions, that is web application firewall solutions. So that is anyway one particular device, or it can be taken in the cloud. So that devices will be there, and that service will be there, which will learn our application, and in that application it will know that these are the known vulnerabilities are there, and that will not be exposed to outside. So that is these all inputs will be required. So now coming to the available platforms. So when we are telling on building a model, and this model, what we are discussing, and what are the options are available. So the various options what are available, mostly there will be some of them will be proprietary, like the platforms which we are running in the current industries, and by the leading OEMs, original equipment manufacturers. So those platforms are available. Apart from that, as I was telling, open platforms are also available, and I will share this that link whatever I found that Google, how they have created for that Gmail security. And here I want to just highlight 2-3 things, like so these are the platforms whatever mostly industry as on today it is used as a service. So it is like Radware, it is one of the OEM, and then IBM Watson, and this big IP is basically from F5 networks, which they all are big industry leaders, which they are creating these platforms for security event analysis. And Siemens, that is they are also having data centers. Over to that, when I'm referring uh, to the security events or security related operations, there will be worldwide organizations also there. So every device has to be qualified. That is called ICSL labs. That link also I will give in my reference. That is International Security Association. So that way they create and certify this type of security products, because I know, as I said, the security is a major concern when it comes to the any data manipulation. So there should be authentication body which should control all these activities, or we should validate all these activities when any product releases. Here I am referring some proprietary products, but I can create open platforms using this models. But when somebody has built a model, how efficient it is, or what process it has to follow to qualify this, so that body is there, and you can refer all of them, whatever big industry leaders I am referring to, IBM, Radware, F5, Siemens, those are there. They all are part of those associations when it comes to security events analysis. Now coming to the OpenAI platform. OpenAI platform, as we know that many platforms are there. Now this, while using this platform, and we got the data for the different layers. So once again, I am going to the previous PPT, because the major focus here is we have defined that class of data which is required for our actions. So they are classified into the layers like physical systems, networks, and data security or application security. Then each layer or each actions, what are the devices or what are the sources are there, that is also being given as input to this model, and each source of data is being fed to our model, which we discussed in the previous first initial slides. That data sources, to get a proper AI enabled platform, I should have proper validated data, then over to that model, and then model will have the ground validation or kind of validation. So now coming to some of the references which I feel when we are discussing about security events, mostly security events, I discussed that ICSL labs and whatever Dev Central, some development platforms are there. You can see very interesting discussion also going on in terms of R&D or in terms of building any platform related to AI. Because when you talk AI on other platforms and in security platform, that validation bodies are there, as I said, and this validation body here also I have given this link of this ICSL lab, that is in International Council for Security Analysis. That lab is there, and there suppose we give any solution or give any kind of solution we want to position, we can refer like referring to benchmarking figures for other products called as storages and servers, like specification benchmarking figures are there. So this kind of benchmarking figures are there for security devices, and from there we can get confidence. Yes, these devices will give me proper input data for my model, and of course these are the some of the more references are there which are used for this, and maybe we can discuss if any specific questions are there. And I hope I have conveyed the major thing is the data sources for particular building a model, and each layer how they are being classified. So these all happens, and when we know, and nowadays earlier people used to talk about network operation center. Now security operation center is there very much in all the leading data centers, because the security has become so important activity. There will be a dedicated team and operation center will be there in all the major data centers. So that way the criticality of these operations are linked, and the events are being monitored not manually but this models building over this AI platform. So maybe that's all from my end. We have to discuss if any specific questions are there.
Thank you, sir. If anyone have any queries, then please drop it in the chat box so that sir can clarify it.
Oh, I have to stop. Huh?
Yes, sir, which type of security mechanisms you have followed in for your security purpose in ISRO? Can we know?
Yeah, ISRO means, see, as I told you, there are different level of security. It's like when it comes to web application, then that only will refer here. Or because we have security itself, to expose the security itself is another security violation. So what I can say here is only in terms of web application. I will refer what are the things maybe standard practice, but in pinpoint maybe I will not be able to explain you in an open forum. We can have one-to-one discussion for R&D purpose, but in overall I can say the classification what I did is, one is physical level protection, then server level, like OS, and your application level vulnerability tools will be there. They all are being used. Then again, when it comes to vulnerability tools, so what are the vulnerability tools? There will be many vulnerabilities, more than 100 vulnerability different companies are there, or open source companies are also there. So what happens, which is the better tool? Question comes from there. So that validation, when I referred that ICSA lab, you can see that link anytime. They have classified. This is 75% qualified. This is 60% qualified. Like that, the ranking they have given also. So there also we can refer little bit when we choose to the product for particular tools. Okay. Now next comes to the data validation, data level security. So data security, anyway, data security, we know encryption and many kind of stamping we do. Those type of things are there. And towards, so whatever classification what I explained here is because the protection what we are doing is that I will not be able to explain in the open forum, but in general what I told you, that these are the classes of levels of security requirement that we are following, because beyond that there is no other framework, because we have ensured physical level, we have ensured application level, we have ensured server level, then we have ensured data level, then we have to ensure this the standards. What I refer standards is periodic audits, periodic validation, because security is like the moment you implement, if due to certain reason changes will be there, and one body should be validating that. So that validation body also be dynamic, what actions we are doing or what mechanisms we are doing. So only thing my request is I will not be able to open here for particular tools or particular devices, whatever is being used. But I have explained everything, that these are the devices available for this, like web application firewall. That is also we are using here. And DOS, IPS, intrusion prevention, that is also used here. So these all devices which are being used in industry, that is being used. So there is no other specific, because these all are coming under protocols. We know that our OSI model, we have to follow that model level protection, then security is ensured. I hope I have answered your question.
Okay, sir.
Are we left with any more questions? Okay, I think no. So thank you so much, sir. If not phenomenal, I don't know what else to call this presentation you just gave. Thank you very much for making this meeting a really successful one. We really appreciate the time you gave to us. Thank you so much, sir.
Yeah, thank you.
Thank you, sir.
Yeah, thank you. Thank you, sir.
Please attend our last session, and that is the closing ceremony at 4:30 p.m. So all participants are requested to find the link from our WhatsApp group and attend accordingly. And test time will be declared closing ceremony.
Now all the
So closing
participants
ceremony will
are
be at
requested,
closing ceremony will be
to join the next
from.
link.
Yes, madam. Yeah, please. So closing ceremony is from 4:30 to 5:30. So after that, exam test will be conducted, and the time will be informed at the end of the closing ceremony. Okay, thank you all. I hope to see you again.